In this lesson, we'll continue our discussion of learning target number 2, determining the number of particles, moles, or mass of a chemical sample given another of these values. Remember that in the last lesson we discussed that because particles are so tiny, it's impossible for scientists to count them directly. The method we're talking about is how do we use the mass of the sample to determine how many particles are in the sample. These two things are related through the molar mass of the sample. Molar mass, or capital M, is the mass of 1 mole of a substance, in units called grams per mole. This equals the average atomic mass of an element, or the sum of the masses of each atom in a compound. For example, the molar mass of iron is 55.85 grams per mole. This is found by looking at the mass number for the element on the periodic table. However, if you have a molecule such as O2, the molar mass of the O2 compound would be the molar mass of the oxygen times 2, or 32.00 grams per mole. It's the sum of the masses of each of the atoms in the compound. The molar mass of AgI would be the molar mass of silver, 107.87, plus the molar mass of an iodine, 126.90, which equals 234.77 grams per mole. Determine the molar mass for these example compounds and see what you get. Pause the video here until you have all your answers. Here are the answers. You might have been tricked on calcium phosphate because you didn't expand out the brackets. You need to add together 3 calciums and 1 times 2 phosphoruses and 4 times 2, 8 oxygens. The mass of a sample and the number of moles it contains is related through this equation. Little m equals n times big M. Little m stands for the mass of the sample in grams. If you're given kilograms or milligrams, you must convert into grams before plugging a number in for little m. Little n stands for moles, and the big M stands for molar mass. Now, as long as you know what chemical you're in, you're either given the formula or the name of the chemical, you can determine the molar mass using a periodic table. Let's do a couple of examples using the mole to mass conversion equation. Example 4, what mass does a 0.750 mole sample of CO2 have? I know I need to use the m equals n times big M equation because my question is asking me for mass and I'm given moles. Let's sub in what I know. I've got 0.750 moles of CO2, and using that formula I can determine the molar mass of the compound. I'm going to take 1 carbon and 2 oxygens and add their atomic weights together. That gives me 44.01 grams per mole. If I solve for little m using my calculator, I get 33.0075. Now, I need to round my final answer using sig digs. I have 3 sig digs in 0.750. That means I can only report 3 sig digs in my answer. I'm going to round this to 33.0 grams. Example 5 requires us to rearrange the mass and mole equation. It asks how many moles are in a 23.6 gram sample of magnesium chloride. I start by subbing in my 23.6 grams into little n. The question asks me for moles, so I'm going to be solving for little n, and I can determine the molar mass of MgCl2 by using the periodic table. It works out to be 95.21 grams per mole. If I rearrange for little n, to get it by itself, I need to divide by 95.21. My calculator gives me this. Then I round to 3 sigdigs, following my sigdig rules. My original mass has got 3 sigdigs, where the molar mass I used has 4. Example 6 requires us to use both the particle to mole conversion equation and the mass to mole conversion equation. It asks what is the mass of 3.67 times 10 to the 24 formula units of K2O. I first need to figure out how many moles are in that sample by using the equation n equals n times Na. When I sub in what I know, I've got 3.67 times 10 to the 24 formula units of K2O. And I can sub in what Avogadro's number is, because it's a constant, and solve for the moles in the sample. In order to do that, I'm going to take my formula units and divide it by Avogadro's number. That gives me 6.0963 and some more digits on my calculator, but I'll just write down the first 5. In order to answer the question and solve for the mass, I need to use the equation mass equals moles times molar mass. In this case, I'm solving for a little m. The molar mass of K2O works out to be 94.20 grams per mole, using the periodic table. My calculator tells me that I'm going to have 574.27 grams. But here's the original number in the question. It's got 3 sigdigs. I use 3 sigdigs for my Avogadro's number, and I use 4 sigdigs for my molar mass. That means I can only include 3 sigdigs in my final answer. So I'm going to round this to 574 grams. Of course, you can go the opposite direction. If you know the mass of a sample, you can use mass equals moles times molar mass to determine the moles, and then use particles equals moles times Avogadro's number to figure out how many particles are in the sample. This solves the problem of not being able to count atoms individually because they're so small. Try out the mass and mole conversion questions listed on your assignment cover sheet.